Well, hello Cinemeric Nation, and welcome to Simply Cinemeric Live. I'm your host, Chris Pollock, and today we're going to take a look at a relatively new piece of software for Siemens called Protect My Machine 3D Twin. Now, Protect My Machine software is kind of the latest in a series of softwares in the collision protection environment, right? So Protect My Machine is kind of our newest and most advanced feature of collision avoidance. Now, Siemens is no stranger to collision avoidance. We've had products in this space for a long time, and the traditional collision avoidance that we've offered had a very specific task in mind. It was designed to protect my base machine elements. So what do I mean by that? I mean, this spindle should never be able to drive into that table, right? This head should never be able to hit this fourth axis. You know, on a more complicated 5-axis machine, as your trunnion table, let's say, rotates around, my elements of the machine should never collide. Now, what it didn't know, and it was never designed to do, was protect your fixtures. It had no idea where this vise was in space. Your workpiece blank, it didn't know where that was. Your tool holder, it could protect your basic tool geometry, like your length or projection and your diameter, but it had no idea what the tool holder shape was, so there was no kind of holder protection. And this is what led us to develop Protect My Machine 3D Twin. What 3D Twin allows me to do is I can create an entire digital environment of my machine space, including my work holding, my stock material, all my tool holders in their library. And once it's implemented, I'm now protecting that entire space. So, you might see this piece of software over my shoulder here and take a look. And for those of you that are maybe familiar with our digital twin software, Run My Virtual Machine, you might say, boy, that looks very similar. That must be Run My Virtual Machine. And you'd be almost right. So the software is based on the 3D side of Run My Virtual Machine, but this is in fact Protect My Machine 3D Twin. Now there's a fundamental difference between the two products. So the digital twin, Run My Virtual Machine, is designed to kind of be like your own little mini sandbox, right? I can have it in my programming area up in engineering. I can create my entire machining space for validation and proof of concept of a job, and completely independent of the machine tool. Now when it comes to collision avoidance and protecting the machine with Protect My Machine 3D Twin, the difference here is now that model is connected to this machine. So if I come to the machine and I start jogging it, you're going to start to see the model is moving in connection or in time with the machine tool. They're handshaked. So anywhere I ask this machine to go, it's going to know in this 3D space. Now this software, this is sitting on a PC. It could be implemented right in a PC at the machine tool control. That would be one option, quite commonly applied. Or you can actually have it running on an external PC. So in my case, I do happen to have a PC right here. This is where I kind of manage the videos, do my production, and I do a lot of my job preparation here as well. So I opted to install it on this PC. On my machine, this is running our embedded system. So this is running a Linux environment. So in this case, I didn't have a Windows environment to install the software, so I'm using my external PC. Had I had a built-in IPC with Windows, I could apply it here at the control. So what I wanted to do is I wanted to kind of show you the product and go through a little bit what the process would be in setting up a job, and maybe time allowing, we might even get a chance to cut some chips, certainly open up the Q&A to talk. So by all means, as you guys come up with some questions, throw them in the chat. We'll take a look at that at the end. But I did want to kind of show you that process, what that process chain is going to look like. Now there's two ways to set up the software. First, if I'm not using any other additional software and I want to just set it up right in this environment, I can come in, I can import my vices, I can import my holders, I can put my vice in space, I can set up the job. But if I'm already using the digital twin, we've created some very simple ways to take all the work I've already done in setting the job up in my Run My Virtual Machine software and transition it directly into Protect My Machine 3D Twin. So that's the way I set this job up. So that's what we're going to look at today. We're going to kind of jump into our software. We're going to take a look at Run My Virtual Machine, and we're going to now transition this job into Protect. Okay, so what you see on the display, this is my digital twin environment. This is Run My Virtual Machine. Normally you could see the name in the upper left-hand corner, but I do have my little camera view there so you can still see me. But this is where I would have set up the job. So this is a pretty straightforward setup. I have done quite a bit of content on this, so we're not going to get into all the nuances and detail here. I have previously set up the job in this software to kind of save us some time. But let's look at what's unique to the job. So first things first, I'm going to have some kind of a program. Now, in my case, I've established a shared folder, and that's where I see this Programs button. This folder is not only in Run My Virtual Machine, it's a folder on my PC, and that shared folder is also shared with the control. So I have kind of a common working area. If I don't do that, I can absolutely transition the programs over to the control via USB stick or some other method. That's up to you. I also went in and I started doing my setup, right? So I first came into my library, decided how I was going to hold my part. In this case, I'm using a standard 6-inch vise. Created some kind of blank for my stock. That was then installed on the machine, set up for my basic prove out. On my tools, I decided to come in and, bring in the models of my tools, drop them in, bring in some different custom tools. I was drilling and countersinking with two separate tools before, so I wanted to optimize that. So I brought in an STL of this Amugi step drill. This allows me to combine two operations in one, and I also wanted to show you kind of how we would set that up. So here we have all of our tools set up in our library. We have our job set up, and now I would normally go and maybe transition to our auto mode and run my job, right? So this would be my normal process. Oh. Hold on 1 second. Store is active. What is going on here? Oh, I hit my overstore button. I was looking going, what is going on? Overstore is a little like kind of MDI in auto mode. All right, so I can kind of check and do my normal proof of concept like I would do when I'm leveraging my digital twin. So this job was actually programmed out of a CAM system. I believe I used NX for this job, and then I kind of spliced it all together. I did use a main program, sub-program kind of strategy. So if you look back at this job, you see I got my main program here, and then each of my operations will be my individual operations for the toolpath. So, I would normally come in, kind of evaluate all this, system comes down, starts running my job, right? This would be a pretty standard process. And typically at this point, I would be kind of at the end of my use case for my digital twin, because I did a proof of concept, validated that the tools look good, holders look good, I'm happy with my work holding and whatnot. So now I would just transfer the job over to the machine and start building it up. But in this case, now we have our 3D twin as part of this process. So I'm not going to bother simulating the whole thing. You guys, I'm sure, have seen this kind of stuff before. But once I have the kind of setup proved out, now what I can do is I can start to transition data out of Run My Virtual Machine. And it's quite simple. So what I'm going to do is I'm going to go to our little setup gear right here in the upper right-hand corner. Once I come to the gear, I want to decide what am I going to export. Now we give you a bunch of options. I don't need the machine model because that's already there in the software, but I am going to want to grab my library of tools work holding, all that kind of stuff, grab my settings. So just by coming in and selecting export, it's now going to give me the ability of exporting that data. So I'm going to come to maybe my shared folder and just create 3D, a simple file, save it so I can access it from the digital twin side. Now when it comes to my program, since I'm already working on a shared folder, that I don't actually have to transfer. If I wasn't sharing a folder, then I might copy that out to a USB stick or some other method to transition it. You do see we got the 3D export zip file that was exported from the software. So now we can start to kind of transition all of this into the 3D Twin software. Now, one of the things I have previously done, just for the sake of limiting the amount of time needed, I did pre-create the physical tools in the machine control, so you'll see that. But at this point, we can switch to our 3D Twin software. And now I want to import my setup. So initially you look and the machine is kind of blank. It's in its natural state. If I look at my library, I don't have any setups currently in it, no tool adapters, no blanks. Everything is pretty much clear, right? So by going to the same spot, my little gear, and instead of exporting, I choose import archive, I can now bring in all that data that I previously set up. So we come up to our shared folder, find our new export, open it up, and now the system is going to bring that in. Now, one of the things to be aware when I use this method is it is going to wipe out anything that was previously in the library. So that's okay. If I didn't want to do that, let's say I already had some stuff previously set up in my environment, I don't want to lose it, I can also go into each of the library areas and discretely export specific components, right? So I could have just grabbed the vise, sent that over, maybe a couple tool holders if I'm using a lot of common tools. So the process is really kind of up to you how you're going to work it. But in the end, you want to bring that data in from that outside source, hence exporting. Once the export is complete, we're going to get a little pop-up telling us that it's done importing that data that was exported from the previous software, and then we can move on with the next step. And the next step being kind of setting it up in the now machine world. There will be a couple extra steps because there's a few things that I have to accommodate for. So initially, we come back and we see now I have some stuff in my library. So there's my vise, there's my stock. I chose to kind of separate these two. Sometimes you'll do your setup and you'll have the stock already mounted to the vise. In my case, I would make that decision or that choice based on what I know I'm going to be doing. So I may be moving around the stock if I don't have a positive stop. So maybe I want the ability of kind of having them independent of each other. Now you go into your 3D space, we can initially drop in the vise. So I'm going to go to import. I'm going to grab my voice, and this machine has two different mounting locations. Oops, and I grabbed the wrong one. We have my table mounting location or my fourth axis. So here we have a vise kind of dropped in. Yep, so there's a kind of a rough position of the vise. Now, one of the differences here that I have to kind of accommodate for is this vise exactly in the middle of this table? You know, in 3D, I kind of just dropped it on and it's good. But in the real, when I bolt this on, it is probably not. So what I did was I actually established a 0 on this vise to be the top center of the back fixed jaw. And what we're going to do is we're going to actually probe that vise to find its location, and that'll allow us to position the vise in the digital space, and then we're going to connect the models. But step one is I do need to come down and probe it. So if I come to the machine, and we'll just transition to our machine view, I can now start to move things around, give you a little bit more perspective of the view. and we can find the vise. Looks like I'm doing pretty good on time. It's always fun. You kind of manage these presentations. And I try to keep them less than a half hour long, and that's great, but how do you get all the content you're looking for in? So in my case, I decided that I'm going to use G510, our 10th fixture offset, to set up my vise. So I'm not going to go through the whole thing here real quick, but I am going to show you some of it. Now, if you look, and I'm going to kind of rotate around a little bit, take a look at our current position. If I was to bring my tool down, you see I'm nowhere near that vise. On the real machine, I'm right on top of it. But my vise itself has got to be an inch, inch and a half over. So this is why it's so important for me to have some mechanism to align the vise. Now, I do currently have protection active, assuming my model is positioned in the right spot. So here you can see I brought my probe down where it would collide, but now it's just a matter of timing the two. Now, I previously have set this up, but if maybe I'm in a spot where I need to probe this edge, but I can't maybe get down to it because it thinks it's hitting the vise. So if I need to suppress the protection, I can come over to this little toggle and I can turn my protection off. Now, even if my protection's on, let's say we were at least going to find the top of the vise. All right, so maybe I'm setting the top here as I mentioned earlier. Currently, if I was to jog down in Z, you can see I can't actually get to the vise. But when we come into a measuring mode, the system's smart enough to understand that, hey, I'm being asked to probe a part of some type. Because of probing, I have to collide with some type of mechanism. So then what we do is we suppress internally the collision model. We even give you a little message that it's being suppressed during the measurement, and away we go. So I previously found that full center point just like this before. We can kind of get her out of the way. So once I've established that zero, now it's time to connect the two. So we come over, oops, not that view, this view. We come over to our 3D space, and first thing I have to do is I have to at some point tell it that I'm using a specific work offset for this vise. So I can't do any modification of the model while it's mounted, so I'm just going to remove it initially. And then what we're going to do is we're going to go over to our library, we're going to go to our setup, and we're going to open up the vise. Once I've opened it up, here you can see I have my vices set up as my clamping, but what I want to do is I want to go in and I want to go to this little offset, and we have a new feature that you don't see in my virtual machine, which is this reference point option. And what this allows me to do is I can now establish a reference point. I give it a unique name. I can move that position around if it's something other than the zero of the model. In this case, I pre-established my model to where I wanted to set it. And now all I have to do is hit save and save that model modification, go back to machine, drop it right back on my table just like I did before. Initially, you see now it's positioned down off of the connection or joint point or mounting point of the model, but now it's time for me to actually make the connection to the work coordinate. So go over to this reference point bullseye on the right side, select it, and now I can choose if there is a reference point established. Before, if I went to look for this, I wouldn't have seen anything there. I can choose which work coordinate. It didn't choose this. This is just from previous use. I like to use this work coordinate for my vise, but I pick the work coordinate I want, and then I hit the little save or apply button. And by applying it, now the vise positions, and if I was to bring the tool back down. Now we're right on top. It's just off of the vise, right, at a given gap distance, keeping me from crashing. But now you can see it's perfectly aligned. I'm dead center of the vise. I'm dead center in that one. Okay. So that's my step one. Now what's important here, and let's go take a look a little bit closer at the model, is any discrepancy in my model to the real, I have to be cautious and careful of. So in this case, I didn't have a 3D model for that vise. This is a D675. It's a little older Kurt vise. I was able to get a D688, and they look close, but in fact, they're a little bit off. So in my case, if you look really close, you might see it, but there is a gap. My vise is actually floating in the 3D space because the overall stack height of this vise is different. That's okay, just as long as I know and I anticipate it. So since I'm working from the kind of the top down, at least I know my top sections are protected. If this is critical, you're going to need to make sure that the model itself is pretty accurate. Now there is some gap distance we set up to accommodate for any kind of model discrepancies, but wherever I can, I certainly want to be close. Now, the next process is going to be for my blank, right? So here, if I was to bring in my blank right now, it could be positioned anywhere on the table. So let's jump over to our library. I did previously have a work coordinate set up, but I don't have a stop. So we are going to have to adjust that work coordinate. So let's add a reference point. I'm going to call it number 1 because in my case I am going to use G54. I'm going to go back to machine. We can drop in the blank right onto my physical table mounting point. Now you don't see the block because it's down here kind of in the middle because I haven't made the connection. In fact, I think I maybe, let me look at this real quick. I want to make sure that I have the right connection point first for my reference point. So when you come in, I would have been wrong. So by default, it's using the 0 of the model. So I need to position that to where the 0 of my part's going to be. In my case, it's going to be the top center of this part. Now, if I want to move it around, I can click on this little hand and click on points on my model, and it'll shift my 0 around. But what I can't pick on in this case, since there's no feature in the middle, I can't get to the middle perfectly. So I can override this position just by typing in the values right into this field. So now you see my reference point where my G54 is going to be is right there in the center. So we save it, go back over to machine. We're going to again drop it in to the space. Once it's dropped in, I'm going to connect the reference point just like I did before. Reference 1, I want to link it to G54. I want to apply. Now, in this case, my blank is set up to the edge of the vise. So I could leave it there or I could move it. If I wanted to move it, I can do that now. Let's go over to here, grab a little bit of stock. So let's say I decided whether it's maybe I'm doing some in-process probing or just my operator decided this is a better location for my vise or for my part. I would have to now reprobe the part. Want to make sure I have G54 set up. So we're going to grab G54. Okay. Bring my Z down. Now if you kind of watch where the model is, obviously the part is off. I'm going to roughly set it in the middle. Okay. So now I want to find the top just to make sure my top is good. So we're going to measure in Z. Now maybe when I hit the top, I want to leave a little bit of positive offset. because I am going to be machining off the face. My probing is suppressed during the measurement. Now maybe we find the center of my block. So now she's going to go through, it's going to come across, measure, find my center. Now, it's not going to immediately move the model. I do need to just go in and accept this adjustment. So you're going to see that's last. And then we're really ready to run the job. Okay, so if we come back to the full view, all right, so for me to now get it to adjust the block, I just want to jump right back into Setup Manager. I want to click on the component I want to move, and then I can go to Reference Point. It's there. I want to just say Apply, and you see now it has shifted the block to represent more where it represents in the reel. Now we can come out to Machine, and we are ready to run. So, final step if I'm going to run this job. We're going to come over to Program Manager. You see my shared folder here. That's the same folder I was working from in my digital twin. I come into it. You see that export file is there. I'm going to go to my main program. We're going to execute that. Fire up the machine. Oh, I am using a tracking method to validate what my last operation was. So I just want to make sure I'm starting from the beginning. And now as you watch, as the machine moves around, the model is going to move around and stay in track, but I have that full protection. So the system is smart enough to know if the spindle's spinning, right, then it's going to allow me to come in contact with my stock. Looks like I probably should have left a little bit more material. Not a problem. And away she goes, cutting my part. Now, had the spindle not been spinning, had I been in a rapid mode, it would have never allowed these two to hit. I am going to give myself a little bit of coolant here. Hold on one second. I just want to turn on my coolant. And there we go. Now, if you watch it, you're going to kind of see there was a ghost tool in the Z. But if you look closely, I have the ghost tool for X and Y shut off, but you will see how the cut is in front of the actual position of the tool. That's your look ahead. So that's how the system is anticipating if there is a potential crash, where it would be as we come through. So with that being said, let's take a look, see if there were any questions in the chat. Oh, it looks like you guys were really quiet. Oh, we got a hi, Mr. CNC. Well, thank you. I appreciate you coming to the event. Oops, I didn't want to do that. Let me jump here. I'm going to go back to our front view. So, hopefully you guys enjoyed this presentation about Protect My Machine 3D Twin. For sure, like and subscribe. It's very important. We're super happy. We just broke the 1 million views for our Mr. CNC YouTube channel. So now our next milestone is we want to break 10,000 followers. And we are really close. So if you're not a follower of the channel, please make sure you follow the channel and like the videos. Give us plenty of comments. We certainly want to keep producing this type of material for you. So it helps to get the community support. So with that said, I want to again thank everybody for spending a little time with me here. I'm going to finish cutting my part, and I will see you guys next time. Thanks again. Have a great day. Bye-bye.